Good morning and welcome to our webinar on why Wagners choose A&I Fluoropolymer coating for its FRP profiles. What's in it? What are the performance advantages? And what is the most cost-effective way to manage vandalism of the coating? I'm Kelly Stewart, Marketing Manager at Wagners CFT, and I'm here with A&I Coatings Sales Director Ben Gillies and Wagners CFT Lead Research and Development Engineer David Boland. Ben Gillies has more than 19 years' experience in paint and protective coatings across a wide range of industries and has been involved in significant infrastructure projects like North West Rail Link, Sydney Metro, Capital Metro in ACT, Seaford Rail Extension and many tunnelling projects. Ben has a cross-section of experience, having commenced his time at A&I as production manager before moving to research and development and currently sales. Ben has a special interest in ultra-durable coatings. Meanwhile, David Boland has an extensive and broad level of knowledge across the glass fibre composite industry, covering resin systems, adhesives, coatings and fibres. David has been pivotal in forward-thinking development at CFT, which has resulted in the implementation of several cutting-edge manufacturing technologies. Currently, he's working on domestic and international product development across multiple markets, as well as the optimisation of existing products. David will be supporting Ben during the Q&A section of our webinar today and will be available for any Wagners CFT specific coating questions. Before we get started, just a few webinar protocols. We are recording today's event and we'll make the recording public via our YouTube channel. We're going to run through Ben's presentation first and hold any questions until the end. You'll see at the top of your screen there is a chat tab where you can submit a question anytime during the webinar. Those questions will be compiled for discussion at the end of Ben's presentation. So without further ado, I'd like to introduce Ben Gillies from A&I Coating.
Thanks very much, Kelly, and I'd like to thank everybody for joining the webinar today. We're going to be discussing fluoropolymer coatings and their advantages, and we'll have a look at some case studies and talk about Wagners composite fibre technology, which is something we're passionate about. Can you see my screen okay, Kelly?
Sorry, I was on mute. Yes, I can see it.
No worries. Excellent. So just what we'll go over today, a brief introduction as to who A&I are and where we came from, some background on fluoropolymer technology and its benefits, the management of graffiti and vandalism, something we all come across these days, the environmental footprint of fluoropolymers, and then we'll check out some case studies from around Australia and overseas. So a little bit about A&I Coatings. So we started first manufacturing coatings in 1981, and then in the late 1990s we were looking for the most durable coating possible, and that led us to a company called Asahi Glass Company in Japan, owned by the Mitsubishi Group. So AGC are the inventors of fluoropolymer resin, and what we do, we take the resin from AGC, we turn it into paint, which involves the addition of about 15 to 20 different ingredients. So they'll be things like UV stabilisers, dispersing agents, various pigments. And then we supply that paint to Wagners, who apply it to their FRP substrates. And then, of course, the fourth stakeholder in all this is the asset owners. So they might be owners of bridges, boardwalks, jetties, utilities, shade structures. And we'll discuss the benefits for the asset owner of using both composite fibre technology coupled with a fluoropolymer top coat. So a little bit about what fluoropolymer is. It's still not well understood, although it is fast growing in popularity. So fluoropolymer coatings are also referred to as FEVE, which stands for fluoroethylene vinyl ether. So when we're talking about FEVE or fluoropolymer, we're talking about the same thing. Now, in terms of the chemical structure, it's a similar structure to a polyurethane polymer. However, it does have the addition of the fluorine molecule. The key to the durability of fluoropolymers is basically captured in these three statements here. So in a fluoropolymer molecule, the main chain bond energy between the fluoroethylene and the vinyl ether is 414 to 424 kilojoules. Now, the maximum UV energy that hits us here on the Earth's surface is 411 kilojoules. So in essence, the maximum UV energy can't break down the bond in the fluoropolymer molecule. And that's simply why it lasts so long. And then if we look at some of the other paint technologies on the market that have been on the market for a long time, one of them would be polyurethane. Its bond energy is 379 kilojoules. So you can see it's below the maximum UV energy. And that's in essence why it breaks down quicker than fluoropolymer. And we all should understand that the maximum UV energy may only hit at certain times during the day or certain seasons. Nevertheless, it does hit and it does have an effect. So what do fluoropolymers offer? Exceptional UV resistance. So in fact, they're still unparalleled in the market. The closest would be a polyurethane or a polysiloxane that still have roughly a third of the life of the fluoropolymer. They have superior chemical resistance, which also provides an added benefit of being graffiti resistant, which is something we all come across. Excellent thermal resistance. So, for example, if we're supplying paint for a roof, a steel roof, which might get to sort of 80 degrees, that's not a problem and doesn't speed up the degradation. And also minimal film erosion, and we'll have a look at what that looks like on a slide a little bit later. So look at some case studies. This slide here shows the Daiichi Mukiyama Bridge in Japan. And Japan has a lot of great case studies for fluoropolymer because they were the inventor of the fluoropolymer resin. And in fact, they're proving the benefits of reduced maintenance to such an extent that the Japanese government has now mandated that all bridges, both new build and that are coming up for maintenance, must be painted in a fluoropolymer coating. So they've got about 37 years of history, and they're already seeing that monetary benefit of going with the fluoropolymer. So this particular bridge here, there's a bit of a story behind it. The arch section, when it was built, was painted in fluoropolymer. And that was because the arch is hard to get to, it's expensive to maintain, and therefore they want to use the longest lasting coating system. Now, on the approach sections, they thought, well, we can afford to save a little bit of money here. That's easy to get to, easier to maintain. So they used an alkyd on the approach sections. After 16 years, in 2003, you can see that the alkyd was ready for a major maintenance regime. It had completely broken down, whereas the arch section was still in good condition. And it gets better. So this is the same bridge. So they repainted the approach sections in a polyurethane. They thought, well, we'll still save a little bit of money. We won't use a fluoropolymer. And the approach sections after 12 years were in worse shape than the arch section painted in fluoropolymer after 30 years. So it just brings to mind that saying, penny wise, $1 million stupid. It's better to look what's down the track. It's better for the government budget. It's better for the taxpayer. This slide here shows what we call film erosion. So over time, as a coating is subjected to harsh weather patterns, it starts to lose its film build. And that manifests itself in the appearance of chalking, loss of gloss. It looks old, it looks tired. We've all seen those structures. What this slide shows on the left-hand side is a cross-section of a fluoropolymer coated sample. So you've got a primer, an intermediate coat, and a top coat. And up the top here, they've just called it tape. What that is basically a cover for half a panel, so that when you remove the panels from the test structure, you can take off the tape and you can see with and without exposure the difference. So these particular panels were placed on an offshore structure off the coast of Japan. What we have on the left side here is fluoropolymer, and on the right side is polyurethane. After 15 years, you can see the polyurethane has lost 22 to 28 microns of film thickness. The fluoropolymer has lost an average of 1 micron. So the fluoropolymer essentially is still doing its job of protecting the underlying coats, which in turn protect the substrate. So when you actually look at this on a structure, what you'll see is a tired looking coating. It'll be chalky, potentially started to crow's feet. And what it really does is it starts to create a pathway or create a weak spot for corrosion initiators to start to get to the substrate. Now, when we design a new coating system, so we have a lab here in the Southern Highlands with 4 full-time chemists, and they're developing new coatings all the time to provide different benefits. And when we do that, we obviously can't afford to wait 60 years before we release that coating system. So we run accelerated testing. This machine in the photo here is called a QUV machine. And what it does is it pounds the samples with intense UV and then a cycle of humidity and condensation. And it just greatly speeds up the degradation process. So what we can see here is hours exposure in the QUV. And after nearly 5,000 hours exposure, which is equivalent to roughly 25 years real life, the fluoropolymer, Vitraflon is our brand name, the fluoropolymer has gone from 72 gloss units down to 37 gloss units. The polyurethane has gone from 67 to 1, and the polysiloxane from 69 to 1. So right now, these would be looking very tired, ready for a repaint. And what we'll see on the next slide, what this actually looks like. These are the actual samples that we pulled out of the machine. So you can see the fluoropolymer is still fairly glossy. It has changed a little bit in colour to a minor extent, but it is still glossy, which means the coating is intact and still protecting the substrate. Whereas when it starts to get chalky, that's when you start to get film erosion. Now, an added benefit, as we mentioned earlier, of fluoropolymer coatings is their graffiti resistance. People often put fluoropolymer coatings in the same category as something like Teflon. Well, they're both in the fluoropolymer family. They're actually quite different. So Vitraflon, our fluoropolymer, is much closer to a polyurethane paint than it is to something like a Teflon. However, the fluoropolymer does give it that added advantage of being graffiti resistant, which unfortunately for us all is a big problem these days. Now, when we test for graffiti, we test a range of different types of graffiti, which can be seen in this column here. We test the removal rating, with 5 being complete removal and 0 being impossible to remove. And then what we also do, we leave the graffiti on there for certain amounts of time. So in this column here, you can see we've applied the graffiti, then we've placed the sample with the graffiti in our QUV machine for 500 hours, and also in our salt spray cabinet for 500 hours. And you can see some of the items, some of the types of graffiti became a little bit harder to remove, but they all still remove quite easily, because the longer you leave graffiti on a substrate, the harder it is to get off. And now, how do we remove it? So it's actually quite simple. Bunnings have got a product called Muck-Off, which is a very effective graffiti remover, very readily available. However, any graffiti remover at a local paint store is most likely suitable. The way it's removed is you spray the graffiti remover. They usually come in like a squirty bottle. You spray that onto the graffiti, let it sit there for a couple of minutes, which starts to dissolve the graffiti. Then you simply take a rag and water and wipe it off. Some types of graffiti are harder to remove than others. Unfortunately, some graffiti artists are fairly innovative, and sometimes they might need 2 or 3 goes to completely remove the shadowing. Something we all face as well, unfortunately, some people get entertainment from vandalism. So it's something we've got to provide repair procedures for. Again, it's fairly straightforward. There's just a few simple steps to follow. We've all seen where vandals will scratch painted surfaces with keys or other sharp objects, which then needs to be repaired, because if it exposes the substrate, that creates a weak point, which over time will get a lot worse if it's not attended to. So for a simple repaint, the way we would go is as follows. We degrease the affected member. So we can degrease with either a solvent-based degreaser or a water-based degreaser. We just need to make sure we remove any dust, dirt, exhaust grime, basically anything that's going to interfere with the adhesion of the subsequent coating. We then abrade the existing coating with a medium Scotch-Brite. So basically, the way you know when that's done suitably is that you remove the gloss and you create a uniform scratch pattern on the surface. You then apply 2 coats of the Vitriflon fluoropolymer, and you're good to go. Now, when you do perform a repair on site, it's often best to go from one end of the member to the other end of the member. It just makes the repair less obvious. Now, where the vandalism is more substantial, it may actually be cheaper and more cost-effective or more practical to simply unbolt the member and install a new member from Wagners, which again is one of the great advantages of Wagners CFT. There's no welding, there's no site cutting. It's simply a unbolt and bolt in. Now, something that's front of mind on everybody's radar at the moment is the environmental footprint. Now, fluoropolymer coatings have a far reduced environmental footprint because they need such a lower number of repaints over their lifetime. Now, we're currently engaging a third party to provide a life cycle analysis, which we'll make available as soon as we receive it. However, the major benefit of fluoropolymer coatings is that instead of repainting every 20 years, you're repainting every 60 to 120 years. And on the next slide, it shows the reduced activity as a result of that. Now, just a point we'd like to make here, there's been a lot of press around PFAS or perfluoroalkyl substances. They're also known as forever chemicals. In essence, they don't break down. So basically the word on the street is that if they find their way into the environment, they stay there forever, or they could even be into your body, into waterways. So they've received a lot of attention and will be the subject of further regulation. Just want to make the point that fluoropolymer coatings have been exempted from that regulation because it is not a forever chemical. So they break down in a similar fashion to polyurethane coatings. They just take a lot longer to do so. Now, here's what we save with reduced maintenance. So every time we've got to do a repaint, these are the points we've got to go through. And every one of those has an environmental cost as well as a monetary cost. And sometimes, as you can imagine, structures that are hard to get to or need a lot of site mobilisation become very expensive very quickly. So the fact that you only have to do this every 60 to 120 years instead of every 20 years has a massive impact on both the environment, because every one of these activities has some sort of environmental impact, whether it's travel to and from site, whether it's waste disposal. Every time you paint, you release VOCs into the atmosphere. So they all have an impact, and particularly on the budget, on the monetary budget, there's an impact there as well. So what we thought we'd do now is just show a couple of examples of how quickly there's been repaints using certain paint technologies. So this particular bridge here, an Australian project, was painted in 2010 in polysiloxane. It's a government asset. So the photos below are in 2017. That's after 7 years of exposure. You can see on some of the shielded sections, it still retains some kind of red colour. It was a really bright red to start with. On faces exposed to the UV, you can see it's in total disrepair. There's crow's feet cracking, total loss of gloss, chalking. And what that does is it creates a pathway for corrosion initiators. And if you don't do something about it, it can get really bad really quickly, making the maintenance so much more expensive. However, that had to be maintained just 8 years after initial painting, which came out of the government budget. Another project here is in New South Wales, a very significant bridge, 800 tonnes of steel. This bridge here is very visual, very aesthetic. It was painted in a bright orange metallic finish. Now, you can see here on this far right-hand photo, anywhere it's been hit by UV, it's started to go white and chalky. And where it's been shielded, you can see that it's still the original colour. That's only after 5 years. Now, I'd hate to put a price on what it'd be worth to repaint this bridge, but I'd put my money on it being repainted in the next decade, if not sooner. So it's just, I guess, lends weight to the fact that bridges are often repainted because of visual appearance, and a fluoropolymer coating creates a significant saving. This was one of the first projects A&I Coatings supplied for in Australia. It was started in the year 2002. It's now 21 years old, and you can see the vibrancy of that colour. It still looks the same today as the day that cladding was installed. And all these colours are the worst possible colours for fading. So I don't think we'll be seeing a repaint on this building for another 40 years at least. And even then, the coating will be intact. It may have just started to fade slightly. Another project which was more recent, 2013, Cairns Convention Centre, full external repaint using a fluoropolymer coating. So there's a lot of asset owners out there that are proving the benefits of fluoropolymer coatings. And we've now supplied enough coating to cover over 3 million square metres in Australia, and there's additional projects overseas. So this project here, Anzac Boardwalk in Newcastle, is a Wagners CFT project. And if you look at the environment there, it's a pretty corrosive environment. There's breaking surf. It would probably be regarded as a C4, potentially a C5 environment. And what we've got there is a non-ferrous structure. So there's actually no elements on that structure that will corrode, although there is stainless steel, but we know that doesn't corrode anywhere near as fast. Now, an interesting point to make here is on that painted Wagners CFT, there's about 60 microns of paint of fluoropolymer coating. So quite a thin film. If that structure there was built out of mild steel, there's a few steps we need to go through. So we need to abrasive blast the mild steel to a class 2.5 blast. We then need to apply a 3-coat system consisting of zinc-rich epoxy, micaceous iron oxide epoxy, and then a fluoropolymer top coat, totaling around 350 microns. So we'd use roughly 5 times the amount of paint. And in addition to that, we'd be painting 3 times as often as a minimum. If it was mild steel, painting in a polyurethane. So it just, I guess, really highlights the durability of Wagners products in that environment. This project here, another great project in Canada, totally non-ferrous structure over a waterway, so quite a corrosive environment. And the asset owner there is going to prove the benefits of that for decades and decades. Another project in the USA, this time in Florida. So this is a boardwalk over a wetland. So again, a very corrosive environment. There's no steel, so it won't corrode. There's no timber, so it won't rot. It's protected by fluoropolymer coatings. So in addition, it won't fade. To look back at another Australian project, quite significant, Sydney Metro. There's about 110,000 square metres of steel that was painted on that project. The government actually did, or a government consultant did a deep dive to look at what coatings were going to offer the best long-term value for money, and they settled on fluoropolymer. So that wraps us up. Just like to thank everybody for joining and open the floor to questions.
Thanks, Ben. What I might just do first, because I see we don't actually have any questions that have been asked in our chat there yet, is just maybe quickly share a couple of slides about Wagners CFT so that people can gather their thoughts and throw some questions in there and give you a chance to take a breather as well. So Wagners Holdings is an Australian Stock Exchange listed company. It was established in Australia by the Wagner family in 1989. The business now boasts 1,000 employees in 7 countries with manufacturing facilities in Australia, the US and UK, supplying construction materials and services globally. There's 3 main business units, including Wagners Construction Materials and Service Division, which includes cement, fly ash, aggregates, precast concrete, reinforcing steel and bulk haulage services. There's Wagners Composite Fibre Technologies, which we've been discussing today, and Wagners Earth Friendly Concrete. Wagners Holdings is still very much a family business, with Joe, John, Neil and Dennis Wagner actively involved in day-to-day operations. Bear with me just a moment because I've lost my screen. All right. It looks like we've got a chat that's popped up there from Mitch Graham. What are the downsides of FEEV coatings aside from the higher cost than other coatings?
Really good question. To be honest, there's really no other downside. We also manufacture these other coatings that were in the slideshow. So we manufacture polyurethane coatings. We also make polysiloxane coatings. They all have their place, but whenever anybody wants an ultra durable coating system on a structure that's hard to maintain, or really vibrant colours, or for any other reason they need ultra long durability, we go to a fluoropolymer every time. So in terms of application, they're exactly the same to apply. In fact, if we give our fluoropolymer to an applicator, they really can't tell the difference between applying a polyurethane or a fluoropolymer. So there's no added cost in terms of application. There's no added health risks associated with it. So in essence, it is more expensive, but there's no other downside.
Excellent. Thanks so much for that. Michael Warren has also asked a question. You mentioned repair of damaged coating. Any special requirements for treatment around cuts and bolt holes? Yes,
so we do need to pay particular attention to those areas. However, with the Wagners substrate, it doesn't actually require a primer, so our fluoropolymer coating is applied directly. So adhesion isn't an issue if the substrate is exposed. You can just paint directly over the scratch or the damage. The only time you might need to perform any other additional repairs is if the scratch is showing through. Like if it's a really deep scratch, you might have to fill that with a filler, an epoxy filler first. And then you would sand back the epoxy filler and then apply the fluoropolymer as per usual. Apart from that, there's no other treatment apart from those 3 points that were listed in that slide. Good question.
David, did you want to add anything to that one about, how we might specifically deal with damaged coatings with Wagners FRP?
I think Ben touched on the main points in terms of you can directly apply the repair to our substrate without the requirement of any primer. But I think when dealing with a composite profile and bolt holes and cuts through the profile that might be intentional or not, you have to make sure that you seal that cut. So we do follow best practice, which is to ensure any paint that we apply to our structures also is done onto the bolt hole cuts as well and the end cuts, to ensure that any ingress from water or other contaminants is prevented from travelling inside that profile.
Thank you. Murad Tadros has asked a question. Are these coatings also applied to Wagners FRP poles, the ones used in power distribution?
Correct, they are.
Yeah. Did you want to add anything to that, David?
For our power poles in particular, I know that the same products that we use across our entire structural range, there are a few different grades of fluoropolymer that we do use, and we sort of tailor them, depending on what structure we're doing, substructure, top structure, in the poles. But generally the fluoropolymer chemistry is the same across the entire range.
Thank you for that. Ben Albany would like to know, what would cost increase percentage ballpark figure look like for FEVs versus PUs?
Yeah, good question. So as a general rule, a fluoropolymer coating will be roughly 2.5 times more expensive than a polyurethane coating. I find it's really helpful to break it down to extra cost per square metre, because it's not it's not as big as what you would first think. So, for example, on a steel substrate, a 3-coat system might typically cost $95 per square metre, supplied and applied. A fluoropolymer system might cost $100 to $105 supplied and applied. So it's actually not a great increase if you take into account the application costs as well. And then if you look at something like a bridge for bridge maintenance, it ends up such a small percentage that it is totally worthwhile for the amount of money that you save ongoing through reduced maintenance. So I hope that answers your question there.
Thank you. I'm just going to ask this question that we were actually given prior to this webinar today as well. We had an internal customer that just wanted to know, repair due to vandalism, does it void the warranty on the paint?
Good question again. It doesn't void the warranty providing it's applied in accordance with the repair procedure. And we can provide a more substantial repair procedure, obviously, than what was on that slide. So that's not a problem at all.
Okay, great. Thank you. Asmita has asked, is there any special surface preparation prior to FEEV application?
It depends what substrate it's going on to. So we supply fluoropolymer for a large range of substrates. Of course, Wagners CFT, we also supply for steel, aluminium, some plastics. So if we talk about Wagners CFT, though, it basically needs to be degreased before you apply the coating. If we talk about steel, it does need to be blasted to class 2.5 and then primed. And it can almost go onto any substrate. All we need to do is tailor the primer to suit.
David, did you want to add anything to that one? I mean, like what with our special surface prep for Wagners CFT?
If I speak just specifically about our material, our composite material, we've got fairly extensive test history showing that only a solvent cleaning step is required as long as our material's fresh, fairly fresh and undamaged. We found that just the solvent cleaning step, we typically use acetone here to clean the surface, so a heavy acetone clean, and then once that's flashed off, you can spray the paint directly onto the substrate. We've got, as I said, extensive scratch, dolly pull-off lab testing to demonstrate that is an effective method for gaining very good adhesion between the fluoropolymer and our composite material.
Excellent. Peter has asked the question, are FEEV coatings covered by AS 2312?
They are to a certain extent. We are actually working to get them more recognised by the Standards Committee. So at the moment, there is a sub-clause, I just forget which page in AS 2312 it's in, but it essentially speaks to fluoropolymer as a modified polyurethane. So what the Standards Committee has said is, okay, you can use a polyurethane system like a PUR5, for example, but then you can substitute the polyurethane top coat for a fluoropolymer top coat under the guise of a modified polyurethane. So it's in there, but it's fairly veiled, and it does make it confusing for some engineers and architects and specifiers. But we are working to get that rectified with the next revision of AS 2312.
Thank you very much for that question, Peter. I did have another question that was asked earlier. This person said, I haven't heard of fluoropolymer paint technology before. Where is it mainly used?
Yeah, good question. So as I mentioned before, it's used very significantly in Japan. It is definitely making big inroads in other countries. So in the UK, we've supplied for about 60 bridges. So it's made some really good progress there. As I mentioned before, in Australia, we've supplied over fluoropolymer for over 3 million square metres. However, some areas where it has been used for a long time, which people don't tend to realise, is on cladding panels. So everybody probably knows the Alucobond cladding panels or alpolic cladding panels or Vitradual. They're just the aluminium panels you see on high-rise buildings. And they've used fluoropolymers for a good 30 years for a very good reason, that you just can't afford to be up a 40-storey building doing a repaint. So if anybody released an aluminium panel today without a fluoropolymer coating, it would be a non-starter, because the market has grown to expect pre-finished aluminium panel with fluoropolymer. So it just gives a bit of a frame of reference of where it's being used already, and where it adds a benefit.
Great, thank you so much for that. It looks like we may have exhausted the questions that are coming in. So I might just share my screen quickly, and we will just put up this feedback form from today's webinar. I'm just also going to pop a link in the chat. You know, giving us feedback about these webinars that we put together is so valuable to us, because it allows us, you know, to streamline, you know, future content, and answer burning questions that people have as well. So if you can complete that feedback form for today's webinar, you can either just use the QR code that's up on the screen there at the moment, or I've just put the feedback form link in the chat there as well. It'll take you 2 minutes, nice and quick. Also wanted to let you know that this is the last of our webinars for 2023. However, I did want to flag that we have 2 very exciting webinars lined up for February and March. Our February webinar will be to how to reduce embodied carbon in construction with Wagners FRP and meet your 2030 targets, where we will also be introducing Wagners CFT's new internationally recognised and third-party verified environmental product declaration, which you may have seen was officially launched this morning. You can use the QR code that's on the screen there now if you'd like to sign up for that webinar, and I will also put the link in the chat there really quickly for you. In March, we will also be looking at the design and top-down upgrade of Huskisson Mangrove Boardwalk in the Jervis Bay Marine Park of Shoalhaven City Council, with guest speakers Cohen Jurgens from Jurgens Civil and Thomas Schoen from MI Engineers. So if you are interested in that one, keep an eye out for the Wagners CFT monthly newsletter, or on the webinar sign-up page on the Wagners CFT website. So again, you can use the QR code there that's on the screen, or I will pop the link in the chat for you as well. Thanks very much for coming today. From our family to yours, have a safe and very Merry Christmas and Happy New Year. We will see you in 2024. The person who has just put in that last minute question in the chat there, we will circle back to you on that one. Thanks very much for coming. We will just go out on our intro video as well. So thanks very much for coming, and we'll see you guys next year. Have a great Christmas. Thanks very much, Ben and David, for the presentations as well.
Thank you.